All right, we're looking at 8.3 now, where we're graphing the full standard form equation, ax squared plus bx plus c. In this equation, we still have the a value, right out front. That is still the a value as what we had before. So if he's positive, it's going to open up. If he's negative, it's going to open down. What's kind of unique about this equation is the c at the end. That's going to be our y-intercept. Whereas in our last one, you could maybe see the vertex a little bit faster. Here we're going to see the y-intercept. Getting our vertex from this equation, this is our standard form equation. Oops, it's gone. But getting the vertex can be a little bit harder. We have to use the formula negative b over 2a. And there's some really neat reasons for why is it negative b over 2a, but for right now, we're just going to know, and we're going to accept it as a fact, that it is negative b over 2a. So let's look at number 11, and let's try to graph him. So starting off looking at this equation, we see the 3 that's hanging out front. So that's the a value, which is going to tell us, and my tablet's being slow, there it is, my a value, which means he's going to be kind of skinny. It's going to be a vertical stretch by 3. We also see the 4 on the end. That means the y-intercept should be 4. That was part of our rules that we had just right above. The 12 is more difficult to immediately see what it's doing. But we want to find our vertex. Our vertex, we're going to use the formula negative b over 2a. So we're going to have negative 12 over 2 times 3, which is 12 over 6, which is 2. So that value there is the x value of our vertex. So our vertex has an x value of 2. To get the other value, we're just going to plug back into the original formula. So I'm going to say f of 2 is going to be 3 times 2 squared minus 12 times 2 plus 4. This is 3 times 4 minus 24 plus 4. 12 minus 24 plus 4. And what's that going to be? Negative 8? Right, negative 12 plus 4 is going to be negative 8, yes. So right there we discovered that our vertex is at 2, negative 8. The rest of the problem really works very similar to the way that we graphed yesterday. We're going to go ahead and draw in our coordinate plane. Now we draw in our vertex, which is at the point 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our vertex. And now, just like yesterday, we go back to the numbers 1 and 4. Now, our stretch factor here was 3. So I multiply both of these numbers by 3, right? Remember, the 3 is like our a value at the very beginning. So we get 3 and 12. The 3, I go up 3 and then left and right 1 unit. So I'm going to make these orange. So these are going to be orange. Up 1, 2, 3, and then over 1 in both directions, go right like that. And then I'll make the next one green. I'm going to go up 12. So I was at negative 8, and if I go up 12, I need to be at positive 4. 1, 2, 3, 4. So there's our parabola, and now we just need to try to draw it in. There we go. Mine isn't the most beautiful thing, but that's okay. If I wanted it to be a pretty graph, I would have used a graphing calculator. Something to check right here, because this is in standard form and we can get our y-intercept so easily, we look and see, was our y-intercept of our graph reasonable? And we actually did touch it right there at 4, so we did a good job. Now we want to fill out the rest of what it asks for. We want the axis symmetry. Well, the symmetry line is always the x value of our vertex. So he's going to be x equals 2. Then we want a maximum or a minimum. This one has a minimum. So he has a minimum value, a minimum of y equals negative 8. Right? The minimum and the maximum we're talking about like the altitude, the height of our graph. Domain and range. My domain is going to be all reals because there are no domain restrictions. My range is going to be everything above -8. So y is greater than or equal to -8. And then is there anything else? The y-intercept, we want to write that out. The y-intercept is right there at 4. So all of this stuff here, we could have gotten all of that just by knowing the vertex. We didn't really have to wait until we graphed. I oftentimes like to look at my graph whenever I'm writing all this stuff down, but you could go ahead and write it down before graphing. All right, that is number 11. Let's look at number 12. Same style problem, except we're graphing something else here. Like before, I'm going to start off by doing -b over 2a. So I'm going to have -12 over 2 times 2. That's going to be +12 over 4, which is +3. And again, that 3 is the x value of my vertex. So let me go ahead and write that down. My vertex has an x value of 3, and we don't yet know the y value of the vertex. A common issue that sometimes happens here, people will try to grab this 6 and say that the 6 is the other value of our vertex, but that's not correct, because the 6 goes with our y-intercept. We could even write that down right now. Our y-intercept is 6. The 6 does not belong with our vertex. So let's plug in 3, right? This 3, we're going to plug in f of 3 to get the other half of our vertex. So we're going to have 2 times 3 squared minus 12 times 3 plus 6. This is going to be 2 times 9 minus 36 plus 6. That's 18. And then these guys are going to be minus 30. So what's that going to be? 12? Positive 12? No, negative 12. Negative 12. That gave us the y value of our vertex. Now we can go ahead and just start graphing. We're going to do a x-axis and a y-axis. Now unfortunately our vertex is quite low here, right at -12. So let me see if I can go right 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is my vertex. And then like before, I'm going to use the numbers 1 and 4. Those give me the other 4 points. They both are going to plug in, what was our stretch value? I'm thinking that it was 2. Yes, it was 2. So I'm going to put a 2 next to both of those to give me 2 and 8. So for my first set of points here, I'm going to up 2 and over 1, which should put me right about there and there. And then 8. Well, I was at -12, so I should be at -4 then. And there we go. And there's my graph. Oh, you know what? I just graphed that wrong. Let me erase just a little bit. I put in one of my points wrong there. This point should be right there. There we go. The way that I noticed was because this is a y-intercept at -4, but our y-intercept is at +6. So that you always want to be thinking about that and just checking yourself to make sure that you haven't made an error. Let's list out the characteristics of this function here. We can do the domain and the range really easily. My domain is going to be all reals. My range is going to kind of go with my minimum value of y equals -12. My range is going to be y is greater than or equal to -12. And then what's my last thing I need? I need the axis of symmetry. I forgot that. My symmetry line is going to be at x equals +3. And I wrote my y-intercept right up there, so we're good on that. I think that's it. Let me check it once more. Axis of symmetry, vertex, minimum or maximum. We wrote our minimum there. Our domain, range, and y-intercept. Yep, so there it is. Let's look at our next page. Number 13. Now, I'm not going to complete this problem. Actually, I don't know if I'm going to complete either of them. I'm definitely not going to do 14. You guys can do that one on your own if you'd like. And I think that, yep. So we are done with our problems. I want to just show us number 13 here. We're going to put a plus 0 on the end right there. And the rest of the problem works the same as above, but that plus 0 can kind of be weird. Now that's going to tell us that our y-intercept for this guy is going to be at 0. So look out for that whenever you do problem number 13. And then problem number 14, just to get you started here, this -7 is going to be a reflection in the x-axis. So your graph should look facing down whenever you get them graphed. Okay? So there we are. That is section 3. You have 2 more problems that you guys need to finish. But there we have it. This is graphing in standard form. It's not written up here, but you know what? Let's write that. This is standard form. And oftentimes this is the least favorite section. People don't normally like graphing in standard form. And I think next up, let me just make sure so I'm not lying to you. I think next up it's vertex form. If it lets me get there. Yes, this one is called vertex. And it's a lot better. A lot better. All right, there we go. That was section 3, and that's all.